Today we will study how to balance any redox reaction. Now we know that any redox reaction can be balanced by two methods. First method is oxidation number method and second method is half reaction method. So at first we will study how to balance any redox reaction using oxidation number method. Now in the given structure, given reaction, we will balance this reaction using oxidation number method. H plus indicates that medium of this reaction is acidic. Now to balance any redox reaction, we have to follow certain steps. Now the step 1 is, we will calculate the oxidation state of atom which is getting oxidized or reduced. We can see this reaction that manganese atom is getting reduced and sulfur atom is getting oxidized. So we will calculate the oxidation state of manganese and sulfur. Now to calculate oxidation state of any atom, we have to follow certain rules. We know that oxidation state of oxygen in most of its compound is -2. So we assume the oxidation state of manganese to be X. So X plus 4 into -2 is equal to the net charge of that compound, which is equal to -1. So oxidation state of manganese is +7. Similarly, oxidation state of sulfur comes out to be +4. In next step, we will calculate change in oxidation state of atom which is getting oxidized or reduced. Oxidation state of manganese is +7, oxidation state of sulfur is +4, oxidation state of manganese is +2, and oxidation state of sulfur is +6. Now the change in oxidation state is 7 minus 2 is equal to 5 and 6 minus 4 is equal to 2. Now we will write the change in oxidation state above the reactants, which means 5 for MnO4 minus and 2 for SO32 minus. Now we will change in oxidation state and it will become coefficient of the reactant. So coefficient for MnO4 minus becomes 2 and coefficient for SO32 minus becomes 5. Now we will balance that atom which is getting oxidized or reduced in the redox reaction except hydrogen and oxygen. So since manganese is getting reduced and there are 2 manganese in left hand side, so there will be 2 manganese on right hand side. Similarly 5 sulfur in left hand side, so 5 sulfur in right hand side. We can analyze that this reaction is still not balanced. We have to balance the charge in the next step. So we will calculate the total charge on left hand side and we will calculate the total charge on right hand side. So total charge on left hand side is -2 -10 which is equal to -2. Similarly +4 -10 which is equal to -6. Since the medium is acidic in nature, this means we have to balance the charge on both sides using H+. So since total charge on this side is -12 and total charge on this side is -6, so -12 plus 6 is equal to -6. Now in last step, we will balance hydrogen and oxygen atom on both sides. So we can see that in this side there are 6 hydrogen atoms and this side there is no hydrogen atom. So we will balance the 6 hydrogen atoms using 3H. Now we can clearly see that this redox reaction is balanced both atom wise also charge wise. Hello all of you. Previously we studied how to balance any redox reaction by using oxidation number method. Now we will study how to balance any redox reaction by using half reaction method. In this redox reaction, OH minus indicates that medium is basic in nature. So to balance any redox reaction by using half reaction method, we will divide the redox reaction in 2 parts. First is oxidation, second is reduction. We can see that MnO4 minus is getting reduced to MnO2 and I minus is getting oxidized to I2. So we will divide the reaction in 2 parts. Then we will try to balance individual half reaction by using certain method. First we will try to balance oxidation state on both sides. We can see that oxidation state of manganese in this ion is +7 and oxidation state of manganese in this compound is +2. So to convert +7 to +4, we add 3 electrons. Similarly, we can see that there are 2 ionic atoms on this side and only 1 ionic atom on this side. So we multiply this number by 2. Now, we know that oxidation state of ionic in I2 is 0. So total oxidation state on this side becomes 0 and total oxidation state on this side becomes -2. So to convert 0 to -2, we add 2 electrons. Now we will try to balance charge on both sides. We will balance charge on both sides by using OH minus. We can clearly see that total charge on this side is -4 and total charge on this side is 0. So to convert 0 to -4, we add 4 OH minus. In this reaction, charge is already balanced in both sides, which means minus to this side and minus to this side. Now we will try to balance hydrogen and oxygen atom on both sides using H2O. Now we can see that oxygen atom on this side is 4 and oxygen atom on this side is 6. So to convert 4 oxygen atom into 6 oxygen atom, we add 2 H2O. We can see that hydrogen atom also gets automatically balanced on both sides. 4 hydrogen atom, 4 hydrogen atom. Now we multiply both half reaction by a number so that total electron gets cancelled on both the half reaction. We can see that there are 2 electrons on RHS and 3 electrons in LHS. So we multiply this half reaction by 3 and we multiply this half reaction by 2. After multiplying both the half reaction by a suitable number, we will add the half reactions to get a complete redox reaction. Now we can see that this redox reaction is balanced both atom as well as charge balance.